Welcome everyone. This is Muhammad Usman and Zakaria Ahmed with me. And here we are explaining the ICP-8. So I will be explaining ICP-8 Part A and he will be explaining ICP Part B. So the ICP Part A, we have a dataset in diabetes, CSV. So first let's start by importing all the libraries which will be useful in our project, in our assignment. Then here we are loading the dataset in the NumPy array, and then here we are just checking the shape, which is 768 by 9, and the last column is our target column. So that's why while splitting the xtrain and xtest, we are just taking first 8 column as our features and last column as a target. And this is the test size. 25% will be used for our testing. And then these are the shapes of our training and testing dataset. So this is a very simple our sequential model, which have only one dense layer, which was provided by the professor itself. So while it has a only single dense layer, while using this model, we got the accuracy 76%. This is our training accuracy, and this is the plot between the epoch size and the accuracy. Epoch is our 100. So as you can see, as the epoch increases, accuracy is also increases. Then here we just evaluate our data set by using X test and Y test. These data sets are very unknown to the model. And here we get the accuracy of 68%. Now our first task is to add more dense layer and see the accuracy. So here I just added the two more dense layer, and these are the hyperparameter 64 and 128, and so you can say also filters. And this is our activation, which is ReLU. This is the last dense layer, which have activation of sigmoid. And then uh, we have the while compiling our model, we have a loss function, which is binary cross entropy, and the optimizer is Adam. And while fitting the data set, we just use the X train, Y train, epoch size is 100, so it will run 100 times. And the validation space is 0.2%. So 20% of the data is used for validating, and the 80% of the data will use for training. After running, this is our report, classification report of our model. So as you can see, this is our output shape. This is our dense layer 15. And now you can see every time the hyperparameter is increasing. And the last one is the single output, like feature and the target. Now, as we saw, after running the model, our accuracy is increased to has increased to 82% from 68%. However, validation accuracy is still 72%. Now, this is the same graph, accuracies versus epoch. Now, the second part was to validate the data on X test and Y test. So we just validate our data using X test and Y test. And here we got the accuracy 73%, which is also increased from 68% to 73%. Now we need to plot the accuracy for training and validation. As you can see, the blue one is my training accuracy and the orange one is my validation accuracy. And from the graph, you can see the model is slightly overfitting. And the last part is to normalize the data before fitting into the model. So first we fit the X train and then we transform it to make it normalized. And same we did for the test, and we did not touch the labels because they are in a range of 0 and 1, so we don't need to transform them. Now this is the same model but with the normalized value. And lastly, we can see that the training accuracy has increased to 99% and the validation accuracy is 78%. And When we evaluate it, so accuracy comes to 67%. So from the graph, you can see the model is highly overfitting. So that's why for on a new data, it's performing not so very good. So the part B will explain, Zakaria.
Hello, everyone. So part B is almost similar to part A. I'll just quickly go through what's the differences. It's a breast cancer data where our target variable is diagnosis. Diagnosis is in the form of M and B. So I need to map those M and B in numerical form. So that's why I have used dot map function. Also, I have to drop column IDs and unnamed column. Those are unnecessary columns. Rest all of the columns are have numerical data. So after dropping those columns, let's go directly to model fitting. Yep. So this was the initial model given, and then when we run this without adding any dense layers, we saw that our accuracy was around 60 90 something
91.
91. Yeah, so our accuracy is 91%. So after adding that two dense layers with hyperparameters 32 and 64 and 128, we saw our accuracy being increased. Also, we had to reshape the input size as well. So our accuracy increased from 92 to 93 percentage, as well as we could see how it performed on validation data as well. So validation accuracy, we were getting also 93%. And once we plotted both training and validation, we got a very good graph. So that's like almost a very good fit. If the training and validation accuracy are far apart, that is an example of overfitting. So if we go down and we see how we can do normalization, normalization is basically done to increase the computational speed and as well as normalize your data between -1 to 1. And once we perform using standard scaler, we should expect our accuracy to further increase. And then we saw it reaching almost like 100% from 93%. So, which is very good. So plotting that as well on the labels, we got this final graph. Thank you.
Thank you.